Hello. Today we are starting with exam 1, page 8, section 5. We are this section we are supposed to sketch the graph of the function of f of x with the properties we are given with the limits. So on the top right, you could see that the limit I did an example. So the first given, we have the limit as x approaches a negative infinity. We put that arrow. So this is when the limits is approaching negative infinity of f of x. We are given that the f of x is going to be negative infinity. So this means that the function is always going to be down. We're gonna put this here for now because it's the infinity and we don't have like a value, but we know that the graph is going to be going down. This is a trick I use for like anytime we're given like we know that the answer is going to be an odd function, which might go down and up or up and down, or an even number that's going to be the same endpoints. Okay, our next given, we have limit as x approaches positive infinity of f of x, and it's always going to equal 2. So that seems easier. Instead of getting infinity, we get a solid number. So we're just gonna put a number like here, or I mean a line and an arrow, meaning that it won't go past, 2. Okay. And then now we're given limits that have a number as x approaches. So this one, x approaches -7, f of x, of course, don't forget the f of x, equals f -7 equals 0. So this means that when the limit as x approaches -7 of f of x, it's always going to be f of parentheses -7. So this pretty much means that it exists and it's always going to be 7. So this is going to be 7 right here. And since since f of -7 equals 0, as we're given here, we just put it on the 0. Our next limit that we are given is when the limit x approaches 4 from the left side of f of x equals infinity. So this means that when 4 on the left side is approaching infinity, we're just gonna put this right here. I'm actually going to erase this because we already know that when the x approaches infinity, it's going to go down. Okay. So we know that when the limit is approaching 4 from the left side, f of x is going to be infinity. So we know that it's going up here. Our next limit that we're given as x approaches -3 from the left side. I'm sorry, we're gonna actually do the limit when it's positive. I forgot to give you that value. So when 4 is positive, f of x will equal negative infinity. So this means that we're going to be coming down because it's a negative. So it's going to be down because of the negative infinity. This is positive infinity, by the way. We are also given when f of 4, when the function is 4, we get the value of 2. So this means that there's a closed circle on 4, even though that the limits may like say otherwise, like one's going up to infinity and the other's going to negative infinity. That doesn't mean that it's not going to have a value. Some functions are like weird and they have like division, and this makes it all not too complicated, but on the limits, that's how you find out, or that's what we're given. Now for the limit when it approaches 3, -3 from the left side, we get 6. We get 6. Okay, and then this is going to be up here. Let me move this real quick. When f is -3, from the left side, it's going to be 6. All right, imagine that this is 6. My graph doesn't go that high yet. So we know that this graph are, let's keep on going in order to see if these dots connect to each other. Let's find out. So when the limit, it's pretty cool that the givens are, by number, so that makes it easy. So when the limit approaches -3 from the right side, we know, or we're given that f of x equals 2. And we're going to put a dot like on -3 from the right side right here. Be careful with these dots because they might look like a closed or open circle. You can't have two closed circles in the same one because two values can't be the same thing. And where this is actually important because the limit no limits here. We're given that we are given when f is -3, meaning when the value is actually -3, it equals -2. So that means that it's going to be a closed circle on 3, and we're going to make these open circles. So we're going to make this an open circle and 6 an open circle. I'm going to erase some of this because we already have like the arrows and the values. We won't get mixed up. I'll put this from the negative sign and put this from the positive side, meaning this is going to be on the left and this is going to be on the right. Let's erase all of this. Okay, I just erased it all. Okay, we're coming to the end of it. So we're given that as the limit approaches 6, we get f of x equals 0. So let's put that down. 6 is 0, so it's going to be right here. And it's going to be a closed because it's the actual value. Actually, the next given is when f of 6 equals undefined or does not exist. I'm just putting does not exist because I know the abbreviations. So this means that it's actually going to be an open circle. So I take that back. I did not read the next given. That's why you always want to be careful with these like givens. You don't really know the answer until they give it to you. And our last given is when f is 0, it equals 3. So it's this right, or my bad. This is a 2, 1. So we're going to put it at 3, which is right here. So this is the end of our given. So the fun part is, connecting the dots. So since we have an arrow down here, that means that the function is going to be negative. And this is -5, and this is -6 on top, or this is 0, -6. That means we're going to increase by 3. Or my fault, so this is going to be -3, and this is -5. We're going to find the slope real fast. So this is a -2 from the run. It's the rise over run, and this is going to be -6, so it's going to be going up by 3. Or actually, it's going to be 3 on the run. Wait, hold on. My apologies. This is actually -7. Let me erase this real fast. This is -7. So the run is -4 over -6, which is just, let's break it down real fast. That is -3 over 2, or +3 over 2. So since this is the slope, we're gonna put that down 3 over 2. So that means 3 over 2. 3, this is gonna go up by 3. So it's just gonna keep on going and going and going. Or it's gonna be constant for what I know. Could be anything. It just has to cross these dots. Or just has to cross the 7 and the open circle up there. Let me make this a little cleaner. Actually, I believe you don't need to find the slopes because you're just given a limits, you're not given functions, so I apologize for that. But if you want to be clean with it, or not be clean, if you just want to do a little extra work, then you can. Sometimes you get stressed out in the exams. Okay, so we have nothing obstructing when the limit's going this way. And we know it's going to start at -3 at 2 because the limit is approaching it from the right side. It wouldn't be down here because this is the absolute value. This is when it's approaching it. So we're going to go up. Like I said, you don't really need you don't need a slope. You just have to indicate that it's going to infinity when it reaches 4. Kind of like that. I'm sorry for that. Right now, I need like an Apple Pen or something. Okay. Next, we're going to have, oh yeah, we can't forget the value of when 4. We're going to erase this. If you don't remember our given for when f equals 4, it equals 2. Kind of the same over here, but just in the middle when x equals 4. So since we know that, or when f is 4, it's 2. I'm sorry. That's a weird looking 2. So it's going to approach negative infinity. And this is from the right side. So we're going to approach it from the right side. And we're going to go up for when f of 6 equals 0, as it's given to us. And this is an open circle, by the way, because the value of 6 is undefined. This is the limit. And it's going to be going infinity, but never passing 2. Okay, and that's how you graph a function when you have limits. Thank you for watching.